In this video, we're going to take a look at exam revision for circle theorems. Now in this video, what we're going to do here is take a look at exam style questions based on circle theorems. Hopefully the first couple of questions we'll see quite straightforward, pretty simple, and hopefully they will get more difficult as we go. Okay, so what I've got here for my first question is A, B, C, and D, which are all points on the circumference of a circle. Okay, and we can see that from our diagram here. And we're told the angle DAB is equal to 88 degrees, so that's D a base this angle here and angle ABC. So ABC. So this angle here is 95 degrees. And what we want to do is find the size of angle BCD. So angle BCD. So we're looking for this angle obtained between these two lines here. So this angle here. Okay. Well, we need to apply our circle theorems here. So hopefully what you notice here is we've got a quadrilateral, and this is a cyclic quadrilateral because we've got 4 points. All 4 points of our quadrilateral on the circumference of a circle. Okay, so what's the theorem when we have a cyclic quadrilateral? Well, what we can see here is that opposite angles of a cyclic quadrilateral add 280 degrees. So this angle here and this angle here, they add 280 degrees, and same for these two angles here. Okay, they will also add 280 degrees. But we're not concerned about this 95 degrees here or this angle here, just this 88 and this angle here. So what we're saying then is this angle here, so the angle DAB plus the angle BCD is equal to 180 degrees. Okay, that's our theorem here. Now we know the angle DAB is equal to 88 degrees. We don't know the angle BCD. Let's just call that Y. Okay, we're looking to find Y. So 88 degrees plus Y is equal to 180. So what I need to do here now is just solve this as a linear equation. Y is equal to 180 minus 88. So that's going to be 180 minus 88 here. So 0 units minus 8 units. That will give me minus 8 units. 80 minus 8, that will give me 0. And then 100 minus no 100, that would just give me 100. All I need to do now is simplify or evaluate this last part here. So 100 minus 8 is 92. We just got the 0 here, so it just stays as 92. So therefore, this angle here that we've marked as Y is 92 degrees. So angle BCD is equal to 92 degrees. And we now need to give a reason for our solution to part A, which we've already technically answered, and that's because opposite angles in a cyclic quadrilateral. I might make a spelling mistake here. I'm not the best speller, but let's give it a go. So opposite angles in a cyclic quadrilateral add 280 degrees. Okay, and that's all we really need to say. We've demonstrated that with our working here as well. And there we have it. So that's our solution to the very first question. Moving on to the next one here, what I've got now are A and C, which are points on the circumference of a circle with centre O. So we've got A here and C here. And we've got our centre O. Now, BA is a tangent to the circle. So this line here, BA, is a tangent to the circle. So we might need to use that in a moment. And we also know that BOC is a straight line. So from here to here to here, this is a straight line. And we're given that angle ABO is equal to 28 degrees. So this angle here, like we can see, is 28 degrees. What we want to do is evaluate the size of the angle marked X. So how do we do this? Well, to me, looking at this, none of the immediate theorems jump out at us, such as cyclic quadrilaterals. We don't have a quadrilateral. It won't be the alternate segment theorem. It's not going to be double the angle, the circumference or anything like that. So to me, we might need to use the fact that this is a tangent. So what do we know about a tangent to a circle? Well, from the point here at the center, going down, meeting this tangent, this forms an angle of 90 degrees. Okay, so we know this angle here is 90 degrees. We know this angle here is 28 degrees, and what I've actually got here is a triangle. So if I just sketch this in a different color, this is a triangle. And we've already got 2 of the angles, so from there, we can easily evaluate this angle here. Okay, so the angle BOA is going to be equal to 180 because that's the total of the angles in a triangle. If you add all the angles in a triangle, you get 180 degrees, minus 28. And remember, this angle here is 90 degrees, so minus 90. It's a right angle. So if I add these together, it might make it a little bit easier. So 28 plus 90, that would be 118. If that were 30, that would be 120. Take 2 off, we get 118. I've now got 180 minus 118. We're using column subtraction here. 118. 0 minus 8, that would give me minus 8 units. 8 tens minus 1 10, so that's 80 minus 10, that would give me 70. And 100 minus 100 gives me 0. Okay. I've now got 70 minus 8, which gives me 62 there. Okay. We know this angle here is 62 degrees. But we want x. We're not concerned too much about this angle here, but it will help us to work out x. And it makes sense if we can kind of turn this around. We can't really rotate this, but if you notice, these are two angles now on a straight line. Okay, and what do we know about angles on a straight line? Well, they add to 180 degrees. So this angle here plus this angle here is equal to 180. So what we're saying is x plus 62 is equal to 180. So therefore x is equal, so just solving this now as a linear equation, to 180 minus 62, 180 minus 62. So 0 units minus 2 units, that gives me minus 2 units. 8 tens minus 6 tens, so 80. Minus 60 gives me 20. And then finally we've got 100. Minus no hundreds here, so we get 100. Okay. So what I've got then, it's a little bit messy to see here, but I've got 100. Let's do it over here. I've got 100 plus 20 minus 2. So I get 100 plus 20, which is 120, minus 2, giving us 118 there. Okay. And we can see from our diagram that the answer seems sensible. It's clearly greater than a right angle, so we'd expect an answer greater than 90 degrees. If we got something less than 90, then alarm bell should be ringing, double check your solution. But that seems sensible. So x here is equal to 118 degrees there, giving us the solution to our second question. Moving on to the next one now, we've got A, B, and C, which are all points on the circumference of a circle with centre 0. We're given that the angle ACB is equal to 59 degrees. And we're asked to evaluate the size of the angle marked Z, showing it all working clearly. Now, sometimes some of the theorems are easier to see from the shape of the triangles that we're working with and circles that we've got here. Okay, so we've got our circle here and we've got some triangles and quadrilaterals within the circle. So what I notice straight away is I've got this arrow shape. So if I start at A, go all the way up to C, come back down from C to B, and we go back up to the center from both of these points here, and I get this arrow shape. And we know when we've got this arrow shape here, we're likely using the theorem that the angle at the center here is double this angle here at the circumference. Okay, so if this is x, this angle here is 2x. So if this is 59 degrees, this angle here now will be double that. So this angle AOB, so AOB is 2 times 59. So if that was 6, that'd be 120. Subtract 2, that would give me 118. Okay, so this angle here is 118 degrees. But how does this help us solve what Z is? So let's just get rid of the red lines here, just so we can see it a bit better. How does this help us now? Well, let's just take a look at this triangle, because we should be able to deduce something important about this triangle. So we start at the center here, and I've got obviously my three sides to this triangle. We've got this side here, we've got this side here, and we've got our base. Okay. Now, this is the center of our circle. So once we touch a point on the circumference from the circle, what we've got here is a radius. So this is a radius. This is also a radius, but this here isn't a radius. Okay, it's not a diameter, it doesn't go through the center. This is a chord. Okay, but we won't mark that. We're not too concerned about that. But what's important to note here is that if this is a radius and this is also a radius, then they're equal in length. Now, what do we know about these type of triangles? Well, that means this side here is equal to this side. And what I've actually got now is an isosceles triangle. And what's important about an isosceles triangle is that we know the base angles here. So this angle here, Z, is equal to this angle. So this angle here is also Z. Okay. Now we've got this angle here at the top, which is 118. So what I'm saying then is this angle here plus this angle here plus this angle here is equal to 180 degrees. That's what we know about triangles. So if this is Z as well, what we're saying then is 118 plus z, so 2z is equal to 180 degrees. Okay, so let's subtract 118 off both sides here. So what we want to do now is just solve for z. So 2z is equal to 180 minus 118. That's going to be 180 minus 118 here. So 0 units minus 8, that's going to give me minus 8 units. 8 tens minus 110, so 80 minus 10 gives me 70, and 100 minus 100 gives me 0. Okay, so I get 70 minus 8, which is 62. But this is 2z, so what we're saying here is 2z is equal to 62. So clearly, if I want z here now, we do the opposite. Times in by 2, we divide both sides by 2. Okay, so divide both sides by 2. What I get here is z is equal to 62 divided by 2, so half 62, and we get 31 there. Okay, so z in this case is equal to 31 degrees. Okay, and there we have it. So that's our solution to that question. Moving on to the next question now, what we've got here is A, B, and C, which are all points on the circumference of a circle with centre O. Now, the first thing that strikes me here is the angles are not numerical. Okay, so we've got 5x here, got 4x here, so our angles are algebraic. But don't let this put you off. It looks a little bit more complicated, but it's actually not too bad. All we're still using here is our circle theorems. Now, the first thing that we can make note of here is that this line AOC is a diameter. Okay, so it goes through the centre and it's through 2 points here on the circumference. So this is a diameter. Okay, now what do we know that relates circle theorems and diameters? Well, that relates to angles in a semicircle. Okay, so what we're saying here is from these 2 points on our circumference, if we go up these lines, then the angle that's formed, or subtended between these two lines here, is a right angle. Okay, so what else do we know about triangles? Well, we know the sum of the three angles is equal to 180 degrees. So 90 plus 4x plus 5x is equal to 180. So what we're going to do now is just solve this equation here. So I've got 90 plus 9x. So 90 plus 9x is equal to 180. I can now subtract 90 off both sides. So 9x is equal to 180 minus 90, which is 90. And then we just want the value of x, so we divide by this coefficient here. So we divide by 9. So 90 divided by 9, which is equal to 10. Okay, and it's as easy as that. Like you can see, it looks more complicated because we've got algebraic angles, but the actual working isn't too bad. We're just making use of the circle theorems that we're already familiar with. Okay, so for the value of x, and x is equal to 10 there. Okay, so this angle here would be 4 times 10, which is 40 degrees, and this angle here will be 5 times 10, which is 50 degrees. We're not actually asked to give these angles, but just so you're aware, that's what they would be as well. Okay, and there we have it. So that's the solution to that question. Moving on to this question now, I've got A, B, and C, which are all points on the circumference of a circle. We're given that the angle ACD is equal to 115, so it's not too easy to see, but this angle here, so I'm going to do this in a different colour, is 115, so 115. Okay, so 115 degrees, I think I've made it worse. 115 degrees, let's do it there. Okay, I think that's easy enough to see. And we're asked to find the value of x, so this angle here. So how do we actually do this? Well, we need to think about what theorems we're going to use here. And straight away, whenever I see like this triangle here, that's inside my circle, that touches this line here, this tangent at the bottom, then immediately I think about the alternate segment theorem. So what does the alternate segment theorem state? Well, what it states then is that this angle here between the tangent and the chord is equal to this angle here in the triangle. So they're equal. And it also states that this angle here that we're looking for, x, this angle here, x, that we're looking for, is equal to this angle here in my triangle. Okay, so if we can work out this angle here within the triangle, then we can easily work out this angle here. Okay, well, if this is 115, these are on a straight line now. BCD is a straight line. So in that case, we can do 180 minus 115. Okay, because these are on a straight line. So 180 minus 115, do that as column subtraction. So 180 minus 1, 15. 0 minus 5, that gives me minus 5 units. 80 minus 10, that would give me 70. And 100 minus 100, that would give me 0. We've got 70 plus 0 minus 5, so that would give me 65. So this angle here is 65 degrees, okay? So therefore, this angle here now, so x is equal to 65 degrees by the alternate segment theorem, okay? And that's all we really need to say here. By the alternate segment theorem. And there we have it, that's our solution. So like you can see, that one's actually quite straightforward once you can pick out which theorem we need to use. Not really too much work to it. And there we have it, so that's our solution to that question. Taking a look at this question now, I've got A and B, which are points on the circumference of a circle with centre O. We're told CA and CB are tangents to the circle. We're also given that the angle ACB is equal to 41 degrees, so this angle here, we want to find the value of x, showing all working clearly. Okay, so where do we begin here? Well, just by looking at our diagram immediately, we can see that this angle here should definitely be greater than 90. Okay, if we get something less than 90, we know we've done something wrong, so that just gives us a bit of a guide to start with. Now we're also told that CA and CB are tangents to the circle, so straight away we can know that we've got these right angles here, because we're coming from the centre down to this point here on the tangent, so they meet at a right angle. Same again here, okay? Now by looking at this, there isn't really any other circle theorems that we can immediately use. You know, there's nothing that jumps out at us here that we need to use. But what I can notice is that I've actually got a quadrilateral here, so I've got 4 sides. I've got this side here, this side here, this side here, and then finally this side here. So I've got 4 sides, so we've got a quadrilateral. So what do we know about the angles in a quadrilateral? Well, they add to 360 degrees, okay? So if we know this angle here, and this angle here, then we can easily work out the remaining angle in our quadrilateral, okay? Because they sum to 360 degrees. So therefore, I've got 41 plus 90, which is 180, and then we're going to subtract that from 360 to get x. So we're doing 41 plus 180. That's going to give me 221. So these 3 angles here, so 90 plus 41 plus 90 is equal to 221. And what we need to do now to work out x is subtract that from 360. Okay, so x is equal to 360 minus 221. Okay, so 360 minus 221, let's do this using column subtraction here. So 360 minus 221. So 0 units minus 1 unit, that would be minus 1 unit. 60 minus 20, so that's 40. So 6 tens minus 2 tens gives us 40. And 300, so 300 minus 200, that would be 300 minus 200, giving us 100 there. Okay, so add these together now. 100 plus 40 is 140. Subtract 1, we get 139 there. Okay, so x here is equal to 139. And like we said, the answer seems sensible. If we got something less than 90, if we got less than a right angle, then something's definitely gone wrong. It's clearly bigger than a right angle. But if we got something, say, greater than 180, then again, we know that's incorrect because that would be greater than the angles on a straight line. Okay, so always use your answer as a bit of a guide as to whether your answer seems sensible. Just give it a quick check, and it just gives you a bit of a guide as to whether your answer is sensible. Okay, so there we have it. So that's our solution to that question. And that brings us to the end of this video on exam revision for circle theorems.